Today in Math 30-2, we're going to look at topic 7.1, logarithmic functions with a base 10 and base e. First of all, we know that 10 to the power of 3 is 1,000. That's like saying log 10 of 1,000 is equal to 3. 10 to the power of 2 is 100. And we can say that log 10 of 100 is 2. 10 to the power of 1 is 10, so we can say log 10 of 10 is 1. So logs and exponents are very closely related. The log 2 of 8, well, it's like saying, what's that exponent going to be? 2 to what power is 8? And 3 to what power is 81? Well, 2 to the power of 3 is going to be 8, and 3 to the power of 4 is going to be 81. Let's look at some graphs. If we have x and log 10 of x, the value for 0 is undefined, 1 is 0, 10 is 1, 100 is 2, and 1,000 is 3. We just did that up top. If we graph these points, it's going to be a graph that looks just like that. Now let's look at y equals another function, 2 times log 10 of x. If we look at the values, what we're going to find is that it's the same as the first graph, except now we're timesing every value by 2. And instead of 0, 1, 2, 3, it's going to be 0, 2, 4, and 6. So there's going to be a stretch. It's going to be stretched out so that the maximum now is going to be much higher, as you can see. In example 10.1, we're going to, example 1, we're going to predict the x-intercept, the y-intercept, the end behavior, the domain, and the range of this function. Y is 15 log x. Well, because 15 log x is really a times log b of x, we're going to say it's 15 log 10 of x, because there's a default. When they don't give b, b is automatically going to be 10. So in the first two that we did, 1 log 10 of x, 2 log 10 of x. This time we have 15 log 10 of x. If we graphed it, you will notice that the y-intercept, there isn't one. There's only one x-intercept. The end behavior, the graph moves from quadrant 4 to quadrant 1. The domain is x is going to be bigger than 0. It's not going to be equal to 0. It's going to approach 0, but it's never going to touch 0. So it's always going to be greater than 0. And for our range, y is going to be any real number. And you can plug that into your calculator as 15 log x and have a look at it, and you can verify it. We're going to talk a little bit about natural logs as we continue. Y equals the ln of x. That is called the natural logarithm. A logarithm with a base of e is called the natural log, and it's written as ln of x. The functions y equals log e of x, y equals ln of x, and x is equal to e to the power of y are all equal. Let's do some graphing. Y equals ln of x, and y equals e to the power of x. In our first graph of y equals ln of x, you'll notice that it looks just like our exponential function. Our second graph, y2, y equals e to the power of x, looks just like a exponential function. And our last graph, y3 equals x, is just a line that you'll notice that this graph seems to be a reflection of. There's our labels, and we say that the graphs are reflections of each other over the line y equals x. In example 2, we just want to say that e is actually an irrational number that has a value of 2.718, and it just keeps going. Now it asks us to predict the behavior, the y-intercept, the domain, that's his x-intercept, the domain and the range, the number of y-intercepts of the graph y equals -4 times the ln of x. Well, if you looked at the initial picture below of y equals the ln of x, you'll notice it starts way down at the bottom and comes up through 1, 0, and then becomes larger. When it's a negative value, like -4 times the ln of x, we imagine, or I predict, that it's going to start way at the top and then come down through 1, 0 and go the other way. So that's exactly what happens. To predict the behavior, well, it's going to start in quadrant 1 and move to quadrant 4. The y-intercept, number of y-intercepts is 0. There we go, quadrant 1 to quadrant 4. The x-intercept is still at 1. The domain, again, is x is greater than 0. The range is y is going to be any real number. And we're moving on. On our last slide today, we're going to do some graphing. If we graph y equals 5 times 2 to the power of x, well, that's an exponential function. Let's get some points going. X is -1, y is equal to 2.5. If x is 0, y is equal to 5. If x is 1, y is equal to 10. And if x is 2, y is equal to 20. And if you plot those points and drew the line through them, that's what it's going to look like. Our second graph, y equals 2 times 0.1 to the power of x. Again, if we plug in values, -2, -1, 0, 1, and 2, when x is -2, we're going to get 200. X is -1, 20. When x is 0, we're going to get 2. Thank you for stopping. And when x is 1, we get 0.2. And when x is 2, we get 0.02. Now, when you look at these first two graphs, you'll notice that the b value in the first graph, b has a value of 2. It's increasing. In the second graph, we have a decreasing function. Here we have y is equal to 6 times the log of x in the first graph. If you plug in the values, you'll notice that for -1, it's undefined. 0, it's undefined. For 1, when x is 1, y is 0. And when x is 10, y is 6. So that's our graph. In our last one, -2 times the ln of x. Again, here we go. It's a negative logarithmic function, natural logarithmic function. So it starts at the top and ends down in a negative position. So it's moving from quadrant 1 to quadrant 4. Please read the summary on page 419, and then I want you to do page 420, numbers 1 to 8.